chemistry students, this is your lesson on ionic bonding and nomenclature. And if you're taking notes, you should fill in the date that you're taking notes. Just always a good practice. So again, in my class, I am going to provide printed guided notes, but if you don't have that, you can certainly pause the video at appropriate times and take your own notes. So just as a review from a previous lesson in my class, ionic compounds are formed by the electrostatic attraction between positive and negative ions. Charges on an ionic compound must add up to 0 for you to have written the correct formula. Those are the rules. This is because just as many electrons must be lost by metals as gained by nonmetals for the compound to be stable. So in other words, it's a bookkeeping thing. Metals tend to lose electrons to become more stable, nonmetals tend to gain them, and then they are held together because positive and negative forces attract. So just as a review, this is a picture of ionic bonding with just the valence electrons using Lewis dot diagrams. So for making the formula between, or the compound between potassium and bromide, you see potassium will lose its electron. It has just one valence electron. Bromine needs just one to have a full octet. So the electron is transferred. Sodium becomes positive. Bromine becomes negative, and an ionic bond is formed because of the attraction between the positive and the negative. And you'll notice the ratio is going to be 1 to 1 because +1 and -1 equals 0. Now with magnesium, magnesium needs to lose 2 and chlorine only needs to gain 1. So this one magnesium can actually will bond with 2 chloride ions. And again, so it'll lose its 2 chlorine atoms, fill those in, and you'll be left with magnesium 2+ because it lost 2 electrons, and 2 chlorides that each gained 1, and they stick together in this ratio. So the formula would be MgCl2. All right, now we're going to talk a little bit about writing ionic formulas and also naming. So the steps to writing an ionic formula is first you determine the charge on the cation. And you always write the cation first. That is usually going to be a metal. Then you determine the charge on the anion, the negative ion, and you write the anion second. Then you determine the number of cations to anions needed to make the charge equal to 0. That way we know that just as many electrons were lost as were gained. And then we write the formula with the ratio using subscripts, and we're going to do a few examples. All right, so the example here is potassium phosphide. So we'll just follow the directions. We're going to write the cation first. Potassium's a 1+. We'll write the anion second. Phosphorus will form a 3- based on its position on the periodic table. Now, if we are going to have the charges equal 0, then we have to have 3 potassiums to form +3 for every 1 phosphorus. In other words, each one of these potassiums loses an electron. Phosphorus needs 3 and so gains from these 3. So in order for us to have a stable ionic compound between potassium and phosphorus, and we'll talk about naming here in a few minutes, IDE is how you name the anion, then the formula is going to be that ratio, 3 potassiums for every 1 phosphorus, and we're going to use subscripts. So the formula for potassium phosphide would be K3P. And remember, when we write formulas, if there's just one, we usually don't put the subscript 1, or we never do, really. So the formula for potassium phosphide would be K3P. All right, and now there's a shortcut crisscross method to do this. Once you've done the first 2 steps, where you've figured out the ion charges for the cation and the anion, the number that is the charge on the anion will be, usually will be, the subscript on the cation and vice versa. And you can see we just went through this in a longer version, but by using crisscross, we could write it very quickly. Now, let's look at some formulas. Let's see if you can do a few things. So see if you can predict the formula between calcium and nitrogen. And again, if you are watching this video on your own, you're going to want to pause it. Here are a few possibilities. Do you know which one it is? Well, the correct answer would be calcium 3, nitrogen 2. Name of this would actually be calcium nitride. How do I know this? Well, like I said, we wrote down all of the positive ions here. Calcium's a 2+, nitrogen's a 3-. In order for these two to combine in a way such that the net charge is 0, we'd have to have 3 calciums and 2 nitrogens, and that's what's reflected there. Okay, let's do the formula between potassium and sulfur. So again, remember the steps. Figure out the charges and then figure out how many of each you need to have a net charge of 0. So in this case, potassium's a 1 plus, sulfur's a 2 minus. So in order for sulfur to get its 2 electrons, it has to get 1 from each one of these potassiums that only lose 1. This will give you a net charge of 0, and then therefore the formula is K2S. And again, because we have 2 potassiums and 1 sulfur. Notice how we don't normally put the charges in here, okay? Because the overall here is equal to 0, and so we don't need the charges because we know the overall is equal to 0. Okay, let's do one more, and this is a funny one, okay? Remember that ionic formulas actually are always the lowest ratio, okay? So if you use crisscross previously, you have to be careful when the ions are equal and opposite. So we've got magnesium sulfur and sulfur, which would be magnesium sulfide. Which one of these would be correct? And if you wrote MgS, you'd be right. This one would not be correct because it's the lowest. It's not the lowest ratio. And again, it's correct. It adds up to 0. But we always write the lowest ratio for that will be 0. And the lowest ratio that will be 0 for magnesium is 2 plus, sulfur is 2 minus, would just be 1 to 1. Okay, now let's talk a little bit about naming ionic compounds. Okay. We've written the formulas, but how do you name these things? We need to talk chemistry. That's something called nomenclature. That's why the title of this lesson is Ionic Bonding and Nomenclature. Nomenclature means, how do I name it? So ionic compounds don't have middle names. This is really important to remember. They only ever have 2 words in their names, like a first name and a last name. The first name is the cation, just the name of the cation, like sodium, potassium, copper, just the name of the cation. The last name is the anion, and that's almost always a nonmetal or a group of nonmetals called polyatomic ions that we're going to talk about later in this lesson. So every ionic name will have just 2 words in it. What's the name of the cation? What's the name of the anion? Put that together, first and last name. That will be the name of the ionic formula. All right, so here's a couple of examples. And also another thing to point out. When naming ionic compounds, the metal is written first, followed by the nonmetal, whose ending is changed to "ide." So if you have fluorine, it's going to be changed to fluoride. If you have oxygen, it's going to be named oxide. So it's always the first syllable, and then instead of having it go to the end like fluorine, we take the first syllable fluor and change the "ine" to "ide", so fluoride. Or oxygen, the first syllable is ox, so it's oxide. So like nitrogen would be nitride, or sulfur would be sulfide, IDE. And these are called binary ionic compounds because they only contain 2 different types of atoms, a metal cation and a non-metal anion. Okay, so let's see if you can practice this. Now remember, I didn't say anything about prefixes, and you all want to put prefixes on this. And I want to tell you that those di, mono, whatever will be used with covalent compounds, but they are never, ever, ever used for ionic compounds. Okay, just say the names. Okay, so we have Na2O. So what would you name this? What's the cation? What's the anion? And what do you have to do to the anion's name? Well, you should have said sodium oxide because the cation is sodium, the anion is oxygen, and we add IDE. And again, we don't use this like disodium stuff. We don't need to. We know what the charges are, and so there's only one possible formula. Never add a prefix if it's an ionic formula. And again, we'll know it's an ionic formula because there won't be any prefixes, and an ionic compound is usually a metal and a nonmetal almost all the time. Okay, now we're going to talk about these polyatomic ions. Polyatomic ions are groups of nonmetals covalently bonded with a charge. I'm not going to necessarily expect you to memorize them, although we may have a few later on that I'm going to ask you to memorize, but you'll most likely have a table where you're going to be able to look them up. So you'll notice there are a lot of ones that end in ate, ATE, or ITE. What ATE and ITE mean is that there's something bonded with an oxygen. And what a polyatomic means many, so there are groups of atoms that stick together and they have a common charge. So you can sort of think of them as one thing, and I'll show you some pictures here in just a minute. But again, you can see, for example, the difference between nitrate and nitrite. They are both a nitrogen, but nitrate, ATE, has 3 oxygens, whereas nitrite has 2. They're both -1 charge. You'll notice the ATE version always has 1 more oxygen than the IT version. If it has hydrogen in it, like this one, you'll see the word bi in the front, like bicarbonate, bisulfate, because it has a hydrogen in front of it as opposed to just sulfate. You'll learn, if you're cool and love this, you'll learn a lot about this in AP Chem, just a little bit about this, but in our class, you are going to need to be able to read a table in order to pick out the polyatomic that's in the formula. Okay, so again, what does a polyatomic look like? So if we had just nitrogen, nitrogen would just be nitrogen with a 3- charge, or sulfur, sulfur with a 2- charge, or chlorine, chlorine with a 1- charge. What is nitrate? You can see instead of just being nitrogen, you've got nitrogen with these 3 oxygens actually attached to it. It's a covalent bond, which we'll talk about later. But the overall thing acts as a unit. That's why you have the dotted line and has a charge of 1- overall. So you just think of this as one thing. And it's written NO3, 1-. Notice sulfate is S with 4. 2-. So the ATE doesn't mean a number, it just means oxygen. And if you're comparing like the 8 form and the IT form, the 8 form always has 1 more oxygen. So sulfate has 4 oxygens attached to the sulfur, whereas sulfite only has the 3. Now there are a couple of funny ones, like ammonium is the only positive polyatomic. The only time you're going to see not a metal as the cation is when you see ammonium. And hydroxide has hydrogen and oxygen in it bonded, and people sometimes get confused. They call it hydrogen oxide, but this is actually called hydroxide. All right, so for example, picture of sodium nitrate. Sodium's a 1+, nitrate's a 1-, so it's a 1-to-1 ratio. We don't have to figure out the charges on the oxygen. They don't matter. What we want to do is just remember nitrate overall has a 1- charge, and it's not going to make sense. These are all negative. They're covalently bonded. It's not going to make sense to add up all the charges within the oxygen and nitrogen. That's not how it exists. You just have to remember nitrate overall has a 1- charge. Since this is a 1-to-1 ratio, we write the formula NaNO3, just like that. Okay, but what if we were going to do magnesium nitrate? So here's the magnesium, which is a 2+. Here's the nitrate that's a 1-. That doesn't add up to 0. So how many nitrates are we going to need? Well, we're going to need 2, because +2 and -1 and -1 equals 0, that net charge of 0. And that, I know from what we did before, that's why we have the parentheses. We have 2 of these nitrates for every 1 of these magnesiums. So we want to make sure we put it in parentheses to indicate we have 2 of these things, just like as if we had 2 nitrogens or 2 chlorides or whatever. It has to be in the parentheses, and that 3 has to be inside, because what we have 2 of is NO3. So the formula for magnesium nitrate would just be Mg, open parentheses, NO3, close parentheses 2. Again, we don't have a subscript there because we only have 1 magnesium. Okay, polyatomic ions still have just 2 names, okay? The cation and the anion. So a couple of examples. NH4, which is a +1, and Cl- is ammonium chloride, just a 1-to-1, +1, -1. Na3PO4. So again, look at phosphate. You can see it. Is right here. It's a 3-. Sodium we know is a 1+. So that's just going to be sodium phosphate. That'd be different than sodium phosphide. Phosphide wouldn't have the oxygen. Aluminum nitrate. Aluminum's a 3+. Nitrate is right here. It's a 1-. So it would be Al, open parentheses, NO3, because the nitrate's a 1- and the aluminum is a 3+. But again, the names are just the cation and the anion. Okay. All right, so let's try to name this. If you have notes, you should, the chart, you have the chart. If you don't, then you should look this up online as you pause the video. So name KNO3. So that's potassium. What is NO3? Is it nitrogen oxide? Is it nitride? Is it nitrate? Is it nitrate? It is nitrate. NO3 is the nitrate ion. Nitride would just be nitrogen by itself. And this is nonsensical because we know that ionic compounds only have 2 names, no middle name. And this is just would be KNO3 because the nitrate ion is NO3 1-. Okay, let's try this one. Which one do you think it would be? And you should have written magnesium phosphate. There's magnesium, that's phosphate. No prefixes, as I said, you just name. Phosphide would not have oxygen. It would just be the single phosphorus ion. And again, this last one doesn't make sense because ionic compounds only have 2 words in their name. Let's try this one, sodium sulfate. Okay, look it up, see what you think. What formula would you draw? So sodium's A1+, sulfate is A2-. So how do they go together? Like this, Na2SO4, because we need 2 sulfates for every, we need 2 sodiums for every 1 sulfate. How about the formula for ammonium phosphate? Look that one up. See what you think. These are 2 polyatomics. So we have NH4 is a 1+, PO4 is a 3-, so we need 3 NH4s for every 1 PO4. Right, final set of notes. Some transition metals such as iron, copper, nickel, and manganese have more than one common charge or oxidation state. And some larger p-block metals do as well. So like lead and tin. To indicate the charge, since they have more than one, we use a Roman numeral. And these are called multivalent cations. So for example, there are 2 forms of iron, iron 2+ and iron 3+. They don't interchange. They are separate. It's as if you were John and John Jr. You and your dad are different, okay? Iron 2+ is different than iron 3+. But how do you, if somebody says John, both John and John Jr., John Sr. and John Jr. are probably going to answer. So what do? We'll say John Jr. or John Sr. To indicate that. With multivalent cations, we put the charge. This is really important. The charge in this as a Roman numeral. So instead of saying iron junior, we call it iron with a Roman numeral 2 because it's a 2+, and iron 3, a Roman numeral 3 with a 3+. You can see there are other forms, like tin is a 2, or there's also a tin 4, okay? So here are ways of naming. Notice the formula does not have the Roman numeral in it. The formula just is a normal formula. It's the name that has the Roman numeral. So this is iron 3+, because based on the formula, and sorry this is a little bit wonky, it should be a little bit lower, but the formula has 3 chlorides for every 1 iron. So how do I know that's iron 3+ and not iron 2+? Because of the ratio in the formula, and there's the charge. Cobalt, we know, is a 4+, because there are 4 bromines that are all 1-. So this is cobalt 4. Now, we're not going to expect you to remember which ones need Roman numerals. If it's a transition metal, you might want to play it safe and put a Roman numeral in there, but usually they'll indicate it. What's cool about this is if you have the name here, you don't actually need to even look up the metal because the charge is right there. It tells you what the charge is. Sorry, this should also say tin, not RH. All right, so let's name CuSO4. Remember, copper is multivalent. So which one? If SO4 is a 2-, what must this copper be? And right, so again, copper is a 2+, SO4 is a 2-, so our net charge is 0. And because there's also a copper 1 form of the ion, you want to put in, and it's a transition metal, you want to put in the charge in the name, not in the formula. Notice it's not in the formula. Okay, let's try one more. Whoops. Let's do this one. I think I've already told you the answer, but the formula is iron 3 oxide. Why is it iron? Why is it written like this? Look, there's a 2 on that iron. Why is there a 3 there? Because it's not telling you the subscript. It's telling you the charge. So let's go back to my explanation here. So Fe2O3, notice that if it's iron 3+, that would be 6+. O3 would be 6-, no net charge. And remember, the Roman numeral is the charge. Okay, and so that would be your correct answer. And that's your lesson. Hope that it made some sense.